Our third application of derivatives is going to be for business application. So here we go. Economists have a specialized vocabulary for rates of change and derivatives. They call them marginals. So if you ever take a business class, you might hear that term, especially in economics. In a manufacturing operation, the cost of production, we're going to represent that with the C of X function, is a function of X, the number of units produced. So C is the cost, where you plug in X, how many you're producing. So it'll tell you how much it costs to produce X of the units. The marginal cost of production is the rate of change of cost with respect to the level of production. So it is dc dx. So the marginal cost is the derivative of your cost function. For example, suppose that we have this cost function here. This is the number of dollars to produce X radiators. When 8 to 30 radiators are produced. So if you're outside of that interval, 8 to 30, this cost function would not apply. So let's find the average cost of producing 8 to 30 radiators. Now this is very similar to what we did in week 1. This is for finding the average between 2 points of production rates. So we're going to use the same formula that we used back in the olden days to find the average cost. Remember, that was the function evaluated at each point in the, well, we were doing time, now we're doing each stage of production. So 30 minus 8 divided by 30 minus 8. So this is just the formula for average rate of change, yeah, average rate of change, which we said was f of x2 minus f of x1 over x2 minus x1. Or it's very similar to our x plus h formula that we've used recently for the difference quotient. That's the same thing, just we're not using h here because we have 2 distinct points in our production now we want to study. So this is the formula you're going to use. So you have to take your cost function, plug in 30, take your cost function, plug in 8. So let's do that on the side. So cost function at 30. So 30 cubed minus 6 times 30 squared plus 15 times 30. And we also need to plug in 8. So 8 cubed minus 6 times 8 squared plus 15 times 8. All right, grab your handy dandy calculator. 30 raised to the 3rd power minus 6 times 30 squared plus 15 times 30. So here I got 22,050. When I plug in 8, so 8 cubed minus 6 times 8 squared plus 15 times 8. Got 248. So the cost to produce 8 items is $248. The cost to produce 30 items is $22,050. It's a pretty big jump, but you are jumping by 22 units. So that is part of it. All right, so we're going to plug our numbers in. 22,050 minus 248, all divided by, okay, we can go ahead and subtract. 30 minus 8 is 22. So on top, we're going to do our minus. We get 21,802 divided by 22. So divided by 22, $991 is the average cost per unit from 8 to 30 units. Okay, now it is kind of interesting because to make 8 units it only costs $248, but to make 1 more unit it costs on average $991. So apparently in this function, the more units you make, it actually gets more expensive. So at some point it probably goes back down again, but we have to study the function as a whole. And that's something we're going to be doing when we start graphing, when we're studying functions as a whole. Learning where the maximum cost is, learning where the minimum cost is, and trying to find out what the best number to make would be. But for this question, we're just asked about this one interval here. Now let's go and look at part B. Whoops. Find the marginal cost. So remember, we just found the average cost over a wide range of production, so from 8 to 30. Marginal cost, remember, is the average cost at one, or the cost of producing one more unit at a particular moment in production. So we want the marginal cost when 20 radiators are being produced. So what is the cost to produce one more? Now we're not going to use the average cost to do this, we're just going to use the derivative. So the marginal cost is the rate of change of cost with respect to one more radiator produced, or the derivative of your cost function. So to do this, we're going to use our shortcuts. So let me go back up and look at our function. There it is at the top. So to do the derivative of this function, we do each term separately, and we're just using power rule, and the numbers in front, we multiply by the powers that come down. So x cubed, why don't you guys pause the video and work this out, see if you can find the answer. Okay, hopefully you tried it. So you should have 3x squared minus 6 times 2 would be 12, and then 1x left, and then the 15 is all by its lonesome now. Now that's the derivative. We want the derivative at the particular production time where we have 20 radiators being produced. So we're going to plug in 20. So 3 times 20 squared minus 12 times 20 plus 15. So that would be 1200 minus 240 plus 15. Use my calculator to make sure I get that right. Whoops. How about if you punched it into your calculator correctly? There we go. I got $975. All right. So what does this mean? This means approximately it costs $975 to produce the 21st item, 21st radiator. So to produce one more radiator, that's how much it's going to cost. So this is at a fairly expensive moment in time, but remember the average was 991, so we're close to the average here. As far as if this is the best or the worst, we haven't talked about optimizing yet. So that's something that's going to come later in this course. But for now, if you're interested in just that one moment in production, where you're going from 20 to 21, this is approximately how much it would cost based on the cost function to produce one more radiator. So that's your business application. Have fun, study hard, and I'll see you in the next video.